Aloha, how you doing? Here we are on grade 4, recording some grade 4 content, module 2, lesson 9. And the subject is to add and subtract fractions with unrelated units by finding equivalent fractions numerically. Now that may seem like a lot of words, and it seems like a lot of words to me. So we just want to call out that unrelated means they're unrelated. They're not in a fact family. Okay, they're not in a fact family together. So they're not like 3 and 6, right? 3 times 2 is 6. So that would be related in a fact family together. They're more like numbers that won't multiply to make each other, like maybe 4 and 9, right? 4 times something isn't equal to 9. 9 divided by something does not equal 4. So that's unrelated, not in a fact family, okay? Equivalent, right? We're trying to find fractions that are equivalent to each other. Equivalent, you can see the word equal in there, right? So equal fractions numerically, and that means we're using numbers instead of models today to figure out equivalent fractions, all right? So let's jump on in. Here we go. All right, our key question today is, how does thinking about denominators of the fractions help you make like units? Okay, and denominators, right? That's the down part of the fraction. The top part of the fraction is the numerator. That's the top. The denominator is the bottom. That's the one that has to be the same whenever you add and subtract fractions, right? The denominators have to be the same. And that's what we mean here by like. Like means same. So we have to think about our denominators to make same or alike units, all right? I hope that's helping you out, because sometimes the vocabulary can make math difficult, right? And we're all about making math easy. So let's check it out. Here we have 4/9 plus 1/2. Now, these are unrelated, right? They're not in a family together. Just looking at the denominators, just looking at the bottom numbers. 2 times something does not equal 9, and 9 divided by something does not equal 2, right? If you look at the multiplication chart, they're not there together, right? Look at the 2's. Nothing times 2 is equal to 9, okay? So we have to figure it out. So we're going to multiply them by each other, okay? Now, here's a little trick. This is the easiest way, the easiest thing to do to solve unrelated denominators, to multiply them by each other, right? 9 times 2, 2 times 9. You see it right here. Now, it's not always going to give you the smallest denominator. Sometimes your denominator is going to be too big. We're going to talk about that later. But we're going to start with our 4/9. Right here's our 4/9, okay? And we're just going to multiply it by 2 over 2. Now, you already know that you're multiplying the same number on the top and the bottom because this is equal to 1, right? Any number over itself is equal to 1. So I'm going to multiply 4 times 2 and I get 8, and 9 times 2 and I get 18. So 4/9 is equivalent or equal to 8/18, right? And you know, I don't really have time to show you that in a model, but if you think about 9 pieces and 4 of them are colored in, and then I make them all 2 more pieces by multiplying by 2, now I have 18 pieces and 8 of them are colored in, all right? And then I'm going to do the same thing with my 1/2. Here's my 1/2. 1/2 times 9 over 9 is 9/18. Once again, multiplying by the same number on the top and the bottom. And I'm just taking my 1/2. You know what? It's really hard for me not to draw a picture. 1/2. There's my 1/2. And I'm going to break it into 9 pieces by multiplying it by 9. It's still 1/2, right? I have a cake. It's cut into a half, but a whole bunch of people show up. So I need to break it into 9 pieces, 8 lines. 1, 2, 3, 4, 5, 6, 7, 8 lines. Okay, just pretend they're all equal, all right? Now, instead of 1/2, I have 9 out of a total of 18 pieces. All right, I'm just cutting it up. Okay, so now I'm going to take my 8/18 and I'm going to add it to my 9/18. 9 plus 8 is 17. 18ths is my answer, okay? I can't add or subtract fractions unless I have the same denominators. Awesome job. Okay, now let's look at our next one. 2/3 plus 1/4. Now I have some of it left out here, and it might be a good time to pause me and try it on your own, right? I'm trying to release more of the responsibility to you, the learner. So let's look at 3 and 4. Are they related? 3 times something does not equal 4, right? 4 divided by something does not equal 3. Can I multiply them by each other? Sure, I can do that. So I have my 2/3 right here, and I have my little, just my extra long fraction sign because I'm going to multiply it by 4/4. So 2 times 4 is 8, 3 times 4 is 12. I'm changing them to 12ths, right? So 4 times 3, now I'm going to take my 1/4 over here and multiply it by 3/3 is 3/12. Do you see that? Okay. And now I have 8/12 plus 3/12. 8, 9, 10, 11 is 11/12, right? Have to have the same denominator to add them together. You could always pause me here and write that down so you have a copy of it in your notes. Awesome job. Let's go to the next one. Subtraction. Okay, subtraction is exactly the same. I have to have the same denominators. 10 and 4, not in a fact family together. So I can multiply them by each other, right? I can also think about other numbers that might work. So let's just think about 10s because they're easy to think about, right? 10, 20, 30, 40. Well, 40 is the first one that's going to be a multiple of 4, right? 4 times 10 is 40. Nothing else times 4 is going to be 40. So I'm going to have to multiply them by each other. That frequently happens, and that's just fine. Okay? So I rewrote my 8/10. I'm going to multiply it by 4/4. Okay? I rewrote my 3/4. I'm going to multiply it by 10/10. How do I know what to multiply by? The opposite denominator, right? Here I multiplied by 4, here I multiplied by 10, right? And 8 times 4 is 32. I have a addition sign here. This is subtraction, right? Always watch your signs. Okay, so 32 40ths minus 30 40ths, and that would be 2 40ths. Oops, didn't see that down there. Okay, 2 40ths is our final answer. All right. Also, a great time to pause me and write this down. Smile. Okay, good job. Let's go on to our next one. 1/4 plus 2/6. 1/4 plus 2/6. Now, this is a good one to think about whether we should multiply them by each other. Okay, let's just think about our fourths here. I'm just going to write 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. Just going to write out my 4s. You could also look at your multiplication chart. These are called multiples of 4. Okay? Let's look at our 6s. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 4 times 6 is 24. Okay, so what do you notice there? Do you see that I have two 24s, right? If I multiply 4 times 6, I would get 24. If I multiply 6 times 4, I would get 24. But is there something easier? Do you see the 12s as well? Right? So could I change them both to 12s instead of multiplying them together? That's what I'm going to try to do. Okay? So 4 times 3 equals 12. And 6 times 2 equals 12. Am I allowed to do that? I certainly am. I don't have to multiply them by each other. I can multiply them by something that makes a smaller denominator. Then I don't have to deal with bigger numbers. But sometimes it's easier just to remember to multiply them together, depending on how much you understand fractions, right? Okay, so I'm going to multiply the top and the bottom by the same number. That makes 3/12 down here. And then I'm going to multiply the top and the bottom by the same number. And that makes 4/12 down here. 4/12 plus 3/12 is 7/12. Now, what if I would have done the 24 and multiply them by each other, right? Like I said, it's totally fine if you want to multiply them by each other. Let's just look. That would be 1/4 times 6/6 and 2/6 times 4/4. Then I'd have 6/24 and 8/24. 6 plus 8, 14/24. Okay? These two numbers are equivalent, right? If I multiply this times 2, I will get this. Okay? So it's the same amount. This one is just broken into more pieces, and it has higher numbers. So, like I said, depending on how advanced you are in fraction understanding, one way is to always multiply the denominators by each other when you have unrelated numbers, right? Another way is to think about what is the least common multiple that you have there. Okay? Another good time to pause me and write this down in your notes. Okay? 8/9 minus 1/6. Okay, let's see what we can do here. 8/9 times something, 1/6 times something. We could multiply them by each other, but 6 times 9 is 54, and that's some big numbers to deal with. Think about 9s. 9, 18. Ooh, think about 6s. 6, 12, 18. Do you see that? And you can just look at a multiplication chart if you're not too strong on this and look for a common multiple. Okay? So 9 times 2/2 is 16/18. 1/6 times 3/3, right? It's the third one. So that would be 3/18. 16/18 minus 3/18 is 13/18. Okay? Great time to pause me and write this down. Awesome job. Now, I just wanted to address that later in your problem set, you have number 7, like there's a page there, and it says to mentally estimate the sum or difference and circle to show your estimate. And then it says to show your work, which was confusing to me because it says to mentally estimate. But if you think of anything to write down, go ahead and write that down. I just wanted to show you how to do this so you would understand when you get to that part of your problem set. Thank you for listening. I appreciate your attention. This is what I think about. I think about half, okay? Now, 1/2, do you notice that 1 is half of 2, right? And that would be equal to 50 out of 100, right? 50 is half of 100. This is also equal to 1/2. The same as 3/6 or 2/4. These are all equal to a half, okay? So if I think about eighths, 4/8 would be a half, right? 4/8. So if 4/8 is a half, this is less than a half. This is a small amount. And if 2.5/5, or we know this is less than a half, right? 2/5. So I'm thinking about these 2 halves. These are 2 less than halves, right? So if I put 2 numbers that are less than half together, their answer is going to be less than 1. Okay? Just wanted to model how to mentally estimate the sum or difference, and circle to show your estimate. Okay? One more quick thing I wanted to show you, thank you for paying attention, is you can add 3 or even 4 fractions together, and you have to come up with a common denominator for all 3, right? They have to have the same denominator to add them together. So here's an example. And 2 times 5 is 10, right? But 3, so I'm going to have to change them all to 30s. So 1/2 times something is equal to 30. I happen to know that 2 times 15 is 30. That's a good one to know. So that's 15/30. 1/5 times 6 over 6, because 6 times 5 is 30. And then 1/3 times 10 over 10 would be 10/30. And then I can add them all together, okay? I just wanted to show you that you can have more than one fraction, and you have to find common denominators, like denominators for all of them. All right? Thank you so much. I really appreciate you watching, and I hope you're having a great, great day. Aloha.